Hi everybody. Good evening. My name is Anil Dwarkanath. Like Vedant introduced, I'm a cloud solution architect. Been with Microsoft for about 9 years now. Been working on cloud platform primarily for about 4.5 years now, right? So in this session, we're going to look at what does it take to build a cloud application? What does it look like? And also look at some of the technology around AI, right? And how you can build AI-based applications. Okay. So before we get started, I would like to do a quick poll just to get a view of yourself. So today's session primarily be looking at Azure, right? In a sense, what do we do? What can we do on Azure from both cloud computing as well as building AI applications, right? So let's get started now. So what I'm going to cover today is I'm going to look at cloud computing scenarios. So what are the scenarios primarily in the enterprise? What does enterprise use cloud for? Some of the scenarios there, and what are the approaches to host applications on cloud? Basically, cloud computing approaches, and we'll spend a lot of time, at least the main part of this session, into discussing use cases of cloud computing, and then we'll delve into how you can embed infuse AI into those applications, right? And throughout and we'll also be looking at a few demos while talking about use cases, right? And finally, we'll have a Q&A as well. So let's look at cloud computing scenarios. So if you really look at enterprise, any large enterprise, they are kind of fall into one of several industry verticals. So it could be a BFSI, public sector, or government enterprise. It could be a healthcare or education or manufacturing, oil and gas, automotive, retail, telco, media, airlines, high tech, gaming, and a few other industry verticals also. I'm just touching upon a few primary industry verticals over here, right? And where does cloud computing exactly help these enterprises? So we classify them as technology horizontals, right? So you could have run-of-the-mill applications like web applications, portals, internet portals, APIs, right? Desktop as a service, databases like Oracle, SQL that enterprises use, and also for backing up their infrastructure, and also for disaster recovery. So most of these enterprises are hybrid in nature. If you look at any large enterprise, Fortune 500 or even close to them, or even Fortune 1000, most of them have a hybrid strategy from a cloud computing perspective, which means that they already have some kind of a private cloud on premises in their own managed data center, and they would like to use cloud for various other scenarios and use cases. So backup and disaster recovery is one of the key use cases over there. Another technology horizontal where enterprise uses a data platform, where, for example, Hadoop, where they want to spin up a very large Hadoop cluster that can query terabytes, close to today we're talking about petabytes of data, looking at Spark, Cassandra, HBase, Kafka, running the data warehouses, and also high performance computing, right? Another word horizontal is Internet of Things, where they want to manage millions of devices, right? Update and manage them. Event ingestion. So let's say, for example, a retail customer wants to get a view of how the retail portal is getting used. So they want to get clickstream, for example, right? So you'll have millions of concurrent users and they're clicking a whole bunch of links on the portal, and you want to ingest all of those events. So that's another scenario. And you want to use something like events ingestion from a technology perspective. And another one is data transformation. In data transformation, you talk about two things. If you're using a data warehouse, you pretty much talk about ETL, which is extract, transform, and load. If you're looking at Hadoop or a Spark sort of a scenario, you're pretty much looking at extract, load, and transform, right? So again, we'll delve into these concepts maybe in the future sessions, but I just want to talk about a few of the concepts here, right? The horizontal is okay. If you look at any cloud computing scenario, you can actually categorize them into one of these three categories, right? Cloud hosted, cloud optimized, or cloud native. So you say cloud hosted, what we're pretty much looking at is looking at taking their on-premises workloads. It could be VMs, storage, data, whatever it is, networks as well, and hosting the exact same workload on Azure as it is. The IP address also wouldn't change, especially the internal IP addresses, right? They wouldn't change as well. So it's exact whatever workload they have, we're pretty much going to host them in the cloud. So typical scenarios are very large SAP implementations, Oracle workloads, SharePoint workloads, or any cost application that enterprise is looking to consolidate in the cloud. So, for example, on premises they would have had hundreds of servers or even thousands of servers. Now they would want to do kind of an app consolidation, kind of reduce their dev test or even non-prod workloads and move them onto cloud, right? So that's where we can look at something like a cloud hosted model, where we pretty much doing a lift and shift of the workloads from on-prem to cloud. The second category is cloud optimized, where it's kind of same application, but leverages some of the native cloud capabilities. For example, auto scaling or even templating, right? So in the sense, when I'm provisioning an application, I'm not going to say create VM, attach an IP address manually and things like that. I'm going to create a ARM template, right? Configure my resources, could be multiple web applications, databases, networks, storage, so on and so forth. And I'm going to compose applications, some kind of a template, and provision them. Ideal for dev test scenarios, non-prod workloads. In production scenario, I'm going to look at something like an auto scaling that the cloud platform natively provides to me, right? So that kind of falls into the cloud optimized category. And final category is cloud native. So wherein you actually build application native to the cloud platform that enterprises leverage. Examples could be serverless. So customers today are embarking on serverless technology, which means that I don't need to provision compute, in the sense that I don't need to assign any CPU cores or memory or storage, right? I pretty much deploy my application, and the application is going to scale as per the load, in the sense that if there are 1 million users, it's going to create 1 million instances. If the data grows from 1 GB to 1 terabyte or 10 terabytes, it's from an application design perspective, nothing changes. It's just going to consume storage provided by the cloud platform. And platform as a service also plays a vital role if you're building cloud native, in the sense you're no longer really worried about the underlying operating system. You only look at, hey, I need a Tomcat server, I need MySQL database. I don't need whether it's running on Windows, I don't care if it's running on Linux. I just need a MySQL database or a SQL DB with so much of compute and memory, or with some kind of a Tomcat server, a Node.js environment where I can host my application. So that's basically PaaS. So if you're looking at cloud native, so today you'll see a lot of push even from the enterprise to actually go cloud native. The application already hosted on the cloud. And if the building any new applications, especially the CIs are looking at, is there an opportunity for them to build cloud native, because it gives them a lot of efficiency from a cost perspective, manageability, scale, so on and so forth. Okay, so now let's talk about a few use cases, right, of how enterprises are leveraging cloud and what kind of applications they're building. Okay, so one of the customers I would like to talk about is ThyssenKrupp. ThyssenKrupp is into the elevator business. They're a global company. So they have about 12 million elevators moving 1 billion people every day, okay, worldwide. And their mission is to how do you maximize efficiency, availability, service quality, and customer satisfaction. And they want to today to actually change the game from elevator maintenance perspective, using predictive intervention and diagnosis, right? So the idea here is, let's say there's an issue with an elevator, and they send a technician to replace it. The technician needs to go to the site, figure out what the issue is. If a part needs to be replaced, he needs to place an order, and it has to go back to the inventory, see if the order is if the part is in the inventory. If not, again, go back to the supplier and things like that, right? So there's a lot of and in that time, this downtime on the elevator is not serviceable. Now again, the technician has to go back. If the part is not available, he has to again come back to the site to replace a part, and so on and so forth. So now what ThyssenKrupp is thinking is, first of all, can I before the technician goes to the site to replace or to fix our elevator, is there an opportunity for us to provide information to the technician as to say, let's say the brakes is kind of having a problem, or the cables is having a problem, right? So provide that information inside to the technician. So before he goes to the site, he's kind of prepared. He probably takes a fault, a replacement part to the site, because he already knows that a brake could be a failure there, right? So it takes a part to the site, and and when he does an investigation, the probability is that the part is actually with the correct diagnosis, right? In the sense, the brakes, for example, was down. So we're able to provide this kind of information, insights to the technician, thereby reducing the time it takes for him to service the elevator, right? So I just want to show you a quick demo of this scenario here. Let me switch over to the browser. So what you're seeing here is this is a demo site that ThyssenKrupp has built. Like Microsoft has partnered with ThyssenKrupp to build this demo site. Here we're showing this is a subset or a small scale representation. You should be able to see on the map worldwide. You should be able to see all the elevator, all the ThyssenKrupp owned elevators, right? And you'd want to look at something like pick a specific customer and be able to monitor as to what's going on from an elevator perspective, right? So if I just go to one of the customers here. So here, if you see the customer here is an athletic center. So they have 3 elevators here, right? One is a lobby elevator, and a field access elevator, and an office elevator located in 3 different sites. Now, all of this information is could be stored in something like an HBase or a Cassandra database, NoSQL format, right? We have a lot of information stored. What's the model type? What's the model type? When is it scheduled maintenance? What is the status? Is it operational? Is there an issue? What is the predicted health? So this is the key information that we're going to look at, right? And we're going to discuss this specific thing. So if you see here, another thing you'll be noticing is I'm able to monitor the elevator in near real time, right? As to which floor it's currently in, whether the door is open or not, right? Now I can click on a specific elevator and get some deeper insights into the elevator, workings of the elevator, right? So here, if you see, it's basically showing some stats for each floor, right? So it's basically showing some landing reports, how's the elevator behaving on each floor, right? And it's also showing the model type, what's the speed, what's the speed here, what's the average door close time. Now, all of this information is coming from sensors located in each of the elevators, and they're sending data to the cloud here, right? So again, this is an IoT Internet of Things scenario. If you look at it, there are like millions of elevators and probably another hundreds of millions of sensors that are sending data in near real time for us to process it. This is so ThyssenKrupp embarked on cloud because there's no way for ThyssenKrupp to invest on so much infrastructure in each of the regions, each of the countries they are in, right? So they're leveraging Azure here, because Azure is currently today in 42 regions worldwide, right? So in each of the regions, they're able to ingest the sensor data, and we're going to run a machine learning algorithm in the backend that's kind of going to predict the health of the elevator. So if you see here, this particular elevator is showing a 70% health based on the sensor data that we are getting, right? And also it's showing, it's basically also showing a history of how or who kind of ran maintenance on the specific elevator here, right? Now it's also showing when I should actually do a scheduled maintenance, right? Because let's say my scheduled maintenance was on 5th, right? The green line actually tells me whether it's in line with what the scheduled maintenance is in, right? So now as a technician, or from a monitoring perspective, from a monitoring center, right? I can, if for some reason the the health kind of deteriorates much before the scheduled time, I can actually send a replacement or a technician to look at it much before the scheduled maintenance, thereby, kind of reducing a catastrophe or kind of taking a preventive resolution over there, right? So again, so this is, like I said, this is just a small scale demo. If you can really envision it, they have a global command center where they're actually monitoring. Each region has got its own monitoring centers where they're monitoring the elevators, its performance, its health, and so on and so forth. So if you see this particular elevator, which is the number 3 here. Number 3 is office elevator. The office elevator is kind of health is at 95%. Probably the usage is low. And if you look at the lobby elevators, the predicted health is about 83%, and the field access elevator is about predicted health is about 70%. Now, how you're getting this value is through a machine learning process. So can we have a quick poll as to from the audience? How many of you have working knowledge on machine learning or already working on machine learning? So here, I just want to show you how enterprises are leveraging machine learning and cloud platform to enable this scenario of predictive maintenance. So the next use case I want to talk about is Rolls-Royce aircraft engines. So if you already know, Rolls-Royce is the primary jet engine supplier for Boeing and Airbus, right, in the commercial airline business. So today they have about 13,000 engines around the world, and so one of the things one of the issues they're seeing is the data that they're getting from the engine, from the sensors, is kind of increasing rapidly. The volume is kind of increasing rapidly, and they want to fundamentally transform their business, right? So one of the business model they're looking at is they're calling it engine as a service, right? So today they're selling engines, and then they're selling maintenance along with the engine. So the engine price is separate and the maintenance price is separate. So they're looking at an innovative business model where Boeing or Airbus can basically get engine as a service, where the price of the engine as well as maintenance is baked into it, and Rolls-Royce can actually do some kind of, again, like we saw earlier in ThyssenKrupp case, they want to do some kind of a predictive, proactive maintenance on the engines here. So I want to quickly show you a demo as well on this case. Let me just switch over to the demo here. So what I have here is, again, this is a subset or a small scale demo of the actual implementation. So here, what I'm showing you here is sensor data from the engines. These are actual sensor data. You can actually look it up in the public domain. So if you look up a sample flight engine data, you'll be able to get it. So this is using a similar data set, right? Realistic sensor data of a jet engine, but again, simulated, right? So I'm going to just start the simulation. What it does is basically kind of simulates. There are about 4 sensors here on both engines, right? Numbered, sensor 9 to sensor 15. Now, each of these sensors are placed in both engines, engine 1 and engine 2, and we are able to see in near real time the performance of the engine based on the sensor reading, right? So the key parameter here for Rolls-Royce is remaining useful life, or it's called RUL, right? So what is the remaining useful life for the engine, and whether can they predict it, right, based on the sensor readings that they're getting. So in an actual scenario, there are few 100,000 sensors in the when I say 100 to 1,000 sensors, I mean, in the engine. But here, just for representational purpose, I just demo here. So it's only showing you 4 sensors. So based on these readings, can we predict the remaining useful life of an engine before it fails catastrophically, right? So if you see here, simulating some kind of some data from each of the sensors based on the type of the sensor that we have, and if you see here, this is the key reading here. So for now, it's showing you in cycles, right? So it's showing you what is the number of cycles it is currently running. So now it's both of them are at 5 cycles, and how many cycles are pending, right? How many cycles can they continue? So kind of saying that it can run for another 200 cycles. Engine 1 can run for another 185 cycles, and engine 2 can run another 214 cycles. So this kind of prediction helps Rolls-Royce to so if you just give it a minute, I'll just give it probably 10-20 seconds here for it to kind of go to the deterioration mode. It's built into the simulation to actually inject some kind of anomaly, right? And you see that the RUL kind of drops a bit, and it throws a warning. So if that continues, right, for some period of time, then Rolls-Royce can take an action, right, saying that, okay, let's go and investigate what the issue is. It could be a sensor problem, or it could be an actual device or the engine problem itself, right? So this way, it helps Rolls-Royce to kind of get into transform the business into that. I talked about engine as a service, provide that new business model to its end customers, which could be Boeing or Airbus or anybody else, in terms of how they buy engines, going to transform the business, right? So now let me quickly show you how this model is being built. So it's basically pretty much running on platform as a service on Azure. It's leveraging web apps, web services, leveraging storage accounts, basically storage, an IoT hub, where you're able to ingest a lot of data in near real time, right, from the thousands of sensors. And once the data is received, we're going to store it in a transient form in something like an event hub, and from there we're going to process it and put it into a Spark cluster and process it from there. So for processing, we are going to use something like an Azure machine learning. So let me quickly show you an experiment that created here. So we have Azure machine learning gives end users, like a data scientist, a quick way to tap into the data and start experimenting very quickly, instead of setting up a whole bunch of platforms like Python notebooks or R servers and things like that. So pretty much get started with start doing the experimentation. So if you see Azure machine learning of the data, I can do that with some of the built-in libraries. And finally, when I kind of use pretty much some prediction, I'm going to use a decision model here, which could be either a boosted decision tree or just a decision forest. And then I'm going to compare the results, right? So I'm pretty much feeding the same data to both training models, and I'm kind of training this model to kind of come up with the regression score here. And I'm going to evaluate whichever is better. Now, once I've done this, I can pretty much set up a web service, right? So one of the challenges that you'll see in machine learning is now, how do you operationalize this? How do you get into this kind of a mode, like I showed you over here, where I'm constantly creating a feedback loop, where I'm ingesting the data and predicting whether it's going to, from health perspective, whether it has got what's the health or what's the remaining useful life of the device here, right? So and automatically provisions of solving the DTs and return the score, which I can use in my application. That's what is happening over here. The application is actually calling a web service that is provisioned through Machine Studio, and it's being invoked in this application, or we consume this application. And again, it's sending data back to Azure Machine Learning to get the model updated, latest data and some real incidents. Let's say the meaningful life actually came down a bit, and you saw there's a problem with the engine, and that's going to go back into machine learning and retrain the model. So that feedback loop is also built into AML as well. Quick overview, actually, instead of deep dive into this, at least needs a week or so to explain what it takes to build a model, especially from a beginner, from a pure beginner. So let me move to the next. So here, if you see the app here, it basically gives the end user to select a date, a time, and what's the category, whether it's advanced or a beginner, things like that. and this is and the price, right? This is a normal way of handling end user experience. Now, if I build if I add intelligence, I'm going to throw up a warning, right, and say and say on the chosen date, based on the chosen date, based on historical data that I have, I can say that I can notify the user saying, look, this particular date, there's a high chance that high demand, and you better show up early, otherwise you're going to lose your rental, right? So you kind of do an advanced notification. Again, this is built in using machine learning, right? We just talk about how you can build this, right? So you can add some kind of intelligence into this app, right? And also a lift status here, right? So what is the status of the lift? If you go to the ski resort, you'll have a lift that basically takes you to the location from where you can start skiing, right? Now here we are actually predicting wait time, right? Again, so here another scenario here is dining, right? Now this is a normal app that will show you some kind of information on what kind of dining is available. If you add some intelligence to it, you can build a recommendations engine as to say, hey, here's another restaurant that you could check out, right? So we can actually build this pretty easily today with cloud computing. So some of the technology stack that you can leverage is, for example, from a data storage perspective, you can look at a SQL Server with R. We have SQL Server integrated, R Server is already integrated with SQL Server, so you can take this multi-core capability and reduce data ingress, moving outside and inside of the server cluster. So because of the integration, our engine runs inside of the SQL Server instance itself, so the data movement is kind of reduced. That's one way to store your data. Another way is to store on Azure Blob Storage itself, which is my object store. And for collecting the events, let's say in this particular case, mobile app case, when the user taps on the proposed recommendation, I'm going to capture the click stream. And if you can imagine, there could be millions of users who are using your app, and I'm going to ingest all of those click events using an events hub, right? And I'm going to use Azure Machine Learning and Stream Analytics to kind of process those events that I've received. And also, we can use something like an Azure search to search dining restaurants or any other information and make it part of the recommendations. Right? So that kind of a tech stack, high-level tech stack that we can use to build this kind of an application. So that's one scenario there. This is the last topic of the session here. So we're going to look at how we can infuse AI, artificial intelligence. So now, so today, AI is really gaining a lot of ground because of three things. So one is because of big data, this data explosion. So data coming from internet, data coming from mobile apps, sensors, right? So there's an explosion of data that we have, and the algorithms have gotten really powerful. Especially if you look at Microsoft research, we've been working on AI for a couple of decades now, right? And from a accuracy perspective, the Microsoft APIs, especially speech and vision, right, have achieved 95% accuracy, which is highest among in the industry, right? So the algorithms have gotten really powerful and really accurate. And because of the cloud computing platform, you can kind of ingest all of the data that's getting generated and build on top of this, right? So because of this, AI is getting a lot of ground, and a lot of enterprises are trying to build, leverage this and drive transformation to, either it could be to improve efficiency, help employees, so on and so forth, right? So now from a Microsoft perspective, Microsoft AI, right? So what do we offer, right? Or what do we have? So kind of bucketize into like five areas, right? One is solutions. Like we have extensible solutions, like we saw earlier. So the demos I showed you is built from a pre-existing solution, right? You don't need to build everything from scratch. It's about like 50-60% complete. You can bring in your data, tune your algorithms, and maybe change the UI, and you have your custom applications, right? The second thing is cognitive services and the bot framework. So we'll just delve into this cognitive services a bit. We have tools for data science, right? From data preparation, modeling, operationalization. You have something like a data science VM, Azure Machine Learning Studio, right? Which helps your data scientists kind of build models very quickly and iterate on them from experimentation point of view, iterate on them very quickly and create models, right? And also for deep learning purpose, we have something called Cognitive Services Toolkit, or CNTK, right? I'll just quickly show you a demo of this. And of course, we have analytics in the big data source, for example, SQL Server and Spark and things like that. So let me quickly show you a virtual agent, a demo, a bot demo over here. So today, the first thing as a low-hanging fruit, right? What enterprises are adopting is a bot, right? What enterprises are adopting today, at least getting started on this journey, is enabling a bot. So they want to kind of at least solve what we call as L1 or level 1 problems, right? Which kind of self-service, right? So here, if you go to, for example, I just want to show you an example of how Microsoft has implemented a bot framework. So here, if you go to support.microsoft.com, I could ask a question of scoring the entire documentation as to where my issue is or where the resolution is. I could, let's say, for example, have a display resolution issue on my Windows 10, right? So basically, go and say Windows 10 display resolution, right? Now, a couple of things happening here. One is, so if you see, the agent is kind of coming up with responses here, right? So a couple of things happening here. There's something called natural language understanding that's happening, which basically takes this phrase that I've input and it's going to understand what it means. It's going to identify things like, Windows 10 is an operating system, and there's a display here, and it's a resolution or part of the display. So it's going to break it down into multiple entities, as we call it, and then based on what it resolves, it's going to provide a recommendation back. So in this particular case, it's asking me to open display settings and also providing me a link straight away here. So I can just click this, and it's going to open up my settings on my PC, right? So it asks a question back. Again, this is for the feedback loop to complete. So now if I say, did it solve the problem? Yes. So it's going to go back and retrain itself and saying, look, for this particular phrase that was input and for this solution, it was correct. So it's going to mark that. It's going to basically mark that feedback as a positive thing and retrain itself, right? So this feedback is again critical here for the bot to work correctly, right? So this is one bot that I can demo here. Again, so a lot of enterprises are embarking on this as well, because it kind of eases the enterprise to at least leverage the existing resources and refocus them on other key issues. For example, today enterprises are focusing on building bots to solve support tickets, right? Level 1, level 2 support tickets, and if they're not addressed by the bot, they're going to be handed off to an actual person who's going to address it manually, right? So this is a bot framework use case over here. Another demo I would like to, I want to talk about this cognitive services here. So like I said earlier, Microsoft AI has been doing work in the AI space for more than 2 decades actually. And the result of that is basically we have enabled something called cognitive services. We have provided APIs for something like vision, speech, language understanding, knowledge search, right? So to show you a couple of demos on this as well. So what it means for an end user or a developer is I don't need to have expertise to build. I don't need to have expertise in AI, right? I can pretty much consume an API and integrate into my application. Let me quickly show you one such API over here, right? Which is a Vision API. So if you go to this Microsoft, maybe you can find this. If you go to Computer Vision API, so here if you see, I have a bunch of images here. Now if I select a particular image, let me take this image over here, right? So what it's doing is the Computer Vision API is going to take this image and tag it with what it understands or what it sees, right? So here it's seeing there's a person, there's a man, there's a skateboard, and there's is young, and he's jumping, so on and so forth, right? and it also provides some kind of a confidence level as to how accurate it is when it is tagging it, right? Now, if I take another picture here, which is like a moving train, right, in a platform, so it's able to recognize, even though the image is kind of blurred, right? If you see, it's able to tag them as, it's a train, it's a platform, it's a station, somebody's walking, somebody's waiting, there's a suitcase, things like that, right? And also it gives, like I said, it also gives me a confidence level over here. Also, again, this is a black and white photograph. So here it's able to show that there's a skyscraper in this, right? And there's a water body. If you see this, if you see here, this kind of a water here, and it's able to show that there could be a water or a river, things like that, right? So it's really accurate, right? And if I pick up, let's say, a cartoon, right, it's able to identify that it's a drawing. It's also identifying it could be a face in the drawing, right? And it's also saying that it's a line drawing, by the way. And it also can identify groups. So here's a photo of people, and it's able to identify that the posing, there's grass, there's a bunch of people, there's a man, there's a group, there's a woman, and things like that, right? So this is just a snapshot of what a Vision API can do. Let me switch over to another demo here. Let me show you a custom Vision API, right? So here, basically, the Vision API takes any photo that you provide to it, and it's going to come up with what it sees, right? In some cases, for an enterprise scenario, you want something more than that. You want to be very specific for a domain. So in this particular case, I'm doing gears, right? I'm going to identify gears. So what I've done here is I've uploaded a bunch of both spur gears and helical gears, and kind of trained it. So now if you want to do a quick test, let me upload an image here. Let me upload a spur gear image to test it, whether it's going to identify it as a spur gear or not. So if I upload this, so if you see, it came back and said that this is a gear, and it's a type spur with a 97% accuracy, right? Now, if I choose if I choose a helical gear, if I choose this and test it out, it'll come back and tell me that, hey, this is a helical gear, right? With a accuracy of 99.9%. So this is a custom Vision API. So you can pretty much use it to train any domain-specific image. It could be pathology reports. People are doing. I'm working with a couple of enterprises who wants to do analyze pathology reports, right? It takes a lot of work. This is just a starting point, as we call it, right? Let me show you. So this is all running in the cloud, right? Now there are a few scenarios where they want to run on an edge computer, right? And let's say the specific enterprise doesn't have internet connectivity. They wouldn't be able to use these custom APIs or custom Vision or Vision API because they're accessible only from the internet. So here we created a cognitive using CNTK, which is Cognitive Services Toolkit. I can create my own model to something like a Vision, API that you saw, right? So let me choose a model here, which is this is the latest model that I have, 64 MB. So if I choose this and let me load an image here, and let me load an image of something like a Coca-Cola here. And if I just upload this, so if you see, it's able to identify that there's a bottle. It could be a soda bottle, right? Again, this is running locally on my machine. It's not connected to the internet at all, right? Because I've already created a model here using CNTK, and I've trained it with a bunch of images. And it's not as accurate as the Vision API that you saw, but pretty much if you kind of train it a little bit more with with a little bit more amount of data, you can actually get pretty accurate on this as well, right? So this is kind of, if you want to run it on an edge where it doesn't have internet connectivity, this is another way you can implement AI, right? Another demo I wanted to show you was, that's about it actually. So hope you got a view of basically what enterprises are doing, leveraging and how they're leveraging machine learning and AI, what kind of applications you can build, right? How you can infuse some of the Vision, custom Vision APIs into your applications. Like I said, there are a whole bunch of APIs that are there. So let's go back to the slide here. We only saw the vision API. There's speech, there's speaker recognition, right? So in a sense, I can kind of speak and can identify based on my voice, all right? And there's language understanding. We also built text analytics translators for even for Indian languages as well, right? So this is just like I said, tip of the iceberg. If you want to get started, it's very easy to build intelligent applications infused with AI today. So hope this session was useful to you.